This is a problem in which says, this is the first problem on this week's homework. If you begin with 93.7 milliliters of 0.888 molar potassium chloride solution and mix it with 56.5 milliliters of 0.848 molar lead 2 nitrate, how many grams of lead 2 chloride can be formed? And we've got the balanced reaction here. Excuse me. Now, again, this may be a bit of review, but it's worth talking about. Excuse me. We have volume and a molarity of potassium chloride, so we will be able to find moles of potassium chloride. We have a volume, and I'll even use a different color for that. We have a volume and a molarity for our other reactant. So this is definitely a limiting reactant problem. So we will find moles of each of the reactants, and then because there's a 2-to-1 ratio, I'm going to suggest that we find the moles of lead 2 chloride that we can make for each of those, and that's how I'm going to work the problem. So starting with my 93.7 milliliters, so I'm going to convert that into liters by moving the decimal point 3 places to the left. I end up with 0.0937 liters. And from there, I know that my molarity is moles per liter. So I'm going to break my molarity actually into moles of potassium chloride per liter, or per liter of solution. Either way works. And then I'm going to go to use the coefficients to do my mole to mole conversion factor. That's going to be 2 moles of potassium chloride per 1 mole of lead 2 chloride. And some students and some faculty even prefer to stop here. I take the one extra step and actually convert it into grams, so that I can compare my grams for both of them. Different ways of doing it. All that matters is that you develop a comfortable system. I do see a question, when is our next exam? Our next exam is, I believe, the 31st. I don't know. It's right around there. It's at least 2 weeks away. But I'll talk about that more a little later, Anna. And if I don't, please remind me, but I'll try to remember. So let me, I need the molar mass of lead 2 chloride. I see my lead is down here at 207.2 grams. My chloride is 35.45. So I have a 207.2 plus 2 times 35.45, 278.10 grams. So 1 mole of lead 2 chloride is 278.10 grams. And please do always carry at least 4 sig figs for your molar masses. And then I'm carrying a 5th one here just because all of my numbers went to 2 decimal places, but 278.1 would be fine here. Multiplying this out, and I will start here, so 0.0937 times 0.888 divided by 2 times 278.1. I get 11.57 grams of lead 2 chloride that could be made if potassium chloride is my limiting reactant. We'll see if that's true or not. Let's see. Our concentrations are approximately equal, but I've got a little more than half of my milliliters here. So I don't know, there's a 2-to-1 ratio here. We'll see how this turns out. Let's set up the second one. So again, I'm going to be doing 0.0565 liters. I'm going to be using my molarity as moles per liter. And hopefully I'll get this to fit on the page. Now I get 1 mole of lead 2 nitrate for every 1 mole of lead 2 chloride. And then the last step is the same. That's why I say some people stop here and only do the last step once. My method is to do it twice. And I just fit it on the page, I think, there. And I'll do my math down here. 0.0565 times 0.848. And it's just 1-to-1 here, so nothing to do there mathematically. Times 278.1. And I get 13.3. I really do usually round everything to 3 sig figs, so 11.6 grams here. 13.3 grams. If lead 2 nitrate is my limiting reactant. And we know that it's always the smaller amount that you can actually make. And so the answer that we would type in here is 11.6. Because this is a numerical answer problem and it would just ask for 11.6. Any questions about that?